Hey everyone, so my name is Okke, for those who don't know me, and I'm a research scientist at Facebook. Now I know that it's right after lunch, so I want to kind of ease us into the technical afternoon. And to do so, let me start off with an example that I guess everyone here is going to be pretty familiar with. Selling a single ad impression. Now imagine that you're going to a website like the New York Times. They want to sell an ad. And they look at a bunch of different advertisers, and they run an auction to determine which ads get shown. In the early days of internet advertising using auctions, people used the first price auction. The rules will be familiar to people. You collect bids from advertisers, you show the ad with the highest bid, and you charge them whatever they bid. And as we all know, that's not a good thing to do because advertisers will shade their bid. We don't even necessarily know who valued that spot the most. So instead, what we do is we run a second price auction. Almost has the same rules. The only difference here is that we charge the next highest bid. And this kind of solves all of our problems. Now advertisers don't have an incentive to misreport anymore. They report their true values. And so all is good. Or is it? But we're not really interested in selling just a single ad to a single advertiser. An advertiser is interested in running a campaign. So they want to reach potentially millions of different users, and they participate in many, many different auctions. If they were to bid truthfully in each of these auctions and win every time that they should, they may run out of the budget that the marketing department had set for them. So this budget is an important feature that's sort of not captured if we're only looking at an individual auction. And one thing that ad platforms do is they offer a budget management system. So you get to tell the ad platform the budget, and they'll include that and make sure that you don't run out of money. Now, one thing that's been a little bit surprising lately is if you look at many ad platforms, so for example, AdNexus and Google AdX, they've recently moved their auction over to a first price auction. So these are systems where it's part of this larger ecosystem with a budget management system, and then the individual auction is running a first price setting. And the good reaction from people in this room should be, wait, is that a good idea? But remember, it's not even possible to simultaneously elicit valuations and budgets at all. So running individual second price auctions may not be incentive compatible either. So the question that we had is this move, does this make sense? Phrased differently, in the presence of budgets, what are some of the ecosystem properties of having individual first price auctions? We're certainly not the first ones to ask this question. In fact, there's a fairly large, rich literature on this. I'm not going to have time to do justice to the literature, but I want to call out broadly, there's kind of two ways to approach this. One is bidder selection, so not every bidder participates in each auction. The other is bid modification. So instead of bidding the original bid, you're going to lower the bid. Thereby you win fewer auctions, and every time an advertiser wins, they pay less, thereby managing the budget. In the bottom right, there's recent literature that is focused on what are the ecosystem properties in the case of second price auctions. And so in this talk, we're going to focus on the setting for individual first price auctions. We're going to use a model that's very similar to the model by Conitzer et al. From 2018. So what's that model? Or rather, what's our model? The input is as follows. There's a number of buyers, N. There's a number of goods, M. And we're going to say that these are divisible goods. Kind of the motivation behind that is that there's going to be a ton of very similar impressions. And so while it's impossible to win a fraction of one impression, we sort of take fractions of that set, that larger set of similar impressions. And each buyer has the following. They have a valuation for every good. And additionally, they have a budget. So they cannot spend over all of the goods more than BI. So that's the input. What is it that we're looking for? We're looking to find pacing multipliers alpha, one for each bidder, and a fractional allocation of goods to buyers that have the following semantics. the buyer I, if in the auction for good J, shades their bid, or they pace their bid, and the bid that enters the auction is the pacing multiplier times the value that they have for that good. So every buyer bids lower in the auction for that good than their value is. And good J is sold using a first price auction. Now I want to point out two things here. So the first one is that we're focusing on a static problem. So we're not focusing on the decision problem that an advertiser has with an unknown future supply. How should they be choosing the right pacing multiplier? This is sort of given all information, what ought you to pick. And the other thing is that we're assuming known valuations and budgets. Now that's a fairly strong assumption, and you may say, hey, well, if you're interested in important properties of ecosystems, and we know that first price is generally not incentive compatible, shouldn't you really be focusing on the strategic responses of agents? Well, I'll get back to that. We have some empirical results that show that in realistic settings, this doesn't matter that much. But at least for all of the theoretical results, we just assume that we have immediate access to this. And the goal here is to find pacing multipliers so that none of the agents run out of budget. A little bit more formally, what is the solution concept that we care about? First, consider budget feasible set of pacing multipliers, which is a set of pacing multipliers alpha and an allocation x that have the following properties. Now, these properties are mostly just going to encode the fact that these are first price auctions and that we want to respect the budget. So the first one is the price for a good is the highest paced bid for that good. So that's the first price part. Next, the winner of a good needs to be amongst the highest bidders. So if a bidder gets any fraction of an allocation, they better be in the set of highest paced bids for that good. Demanded goods must be sold completely. So if there is a bid for a good, we must sell the entirety of it. Of course, we cannot sell more, so there's no overselling. And then finally, we need to respect the budget constraint as well. So hopefully these constraints all make sense. But there's like a little bit of an issue, which is that there's trivial solutions to this. For example, if I set pacing multiplier 0 and I allocate nothing to anyone, then that satisfies all of the conditions that we have here. So in order to look at cases that are interesting, we define first price pacing equilibria, which are, first of all, they satisfy all of the conditions that I just listed. And additionally, there's no unnecessarily paced bidder. So if a bidder does not spend their entire budget, the only way that that can happen is if their pacing multiplier is exactly 1. So that's mathematically the solution concept that we're interested in. Let's run through an example just to build a little bit of intuition for it. So in this case, we have 2 buyers, we have 2 goods. The buyers have a budget. So the first buyer has a budget of 5. The buyer 2 has a budget of 10. And imagine that they have the following valuations for the good. The first buyer is indifferent between the 2 goods and values them at 10. The second buyer values the first good better at 7 and the other good at 5. I claim that there's a first price pacing equilibria that has pacing multipliers 1/2 for bidder 1 and 1 for bidder 2. Now I also owe you what is the allocation, but let's first run through what the implications of these pacing multipliers are. So the paced bids of buyer 1, because they have pacing multiplier 1/2, their paced bids are going to be half of their values. So in this case, it's going to be 5 and 5. For the second buyer, since the pacing multiplier is 1, their original valuations enter as their bids. This means if we look at the price for good 1, it must be 7, because that's the highest bid. And for good 2, the price must be 5, because both bidders bid 5. So what about the allocation? Well, for good 1, this is really clear, right? There's only a single highest bidder, therefore they must win the entirety of that item. But what about the second good? So we have a tie here, and there's a little bit of leeway that we have in assigning the allocation. But remember that we cannot have any unnecessarily paced bidders. Because buyer 1 is paced, they need to spend their entire budget. Therefore, if they get the entirety of the good, then they spend 5 total, which means that the sum of all of the payments equals to the budget. So that one satisfies the no unnecessary pays bidders. And for buyer 2, so their spend is lower than the budget that they have, but that's okay because they're not paced. So that's an example of what a first price pacing equilibrium can look like. But more generally, what kind of properties can we expect from these objects? Yes.
When you do exactly the pacing,
yep.
what is the factor that you are doing this test? Can you explain a little bit more the process of pacing?
Absolutely, yeah. So pacing means we pick pacing multipliers. In this case, I picked multipliers alpha 1 being equal to 1/2, alpha 2 being equal to 1. That means that for each of the goods, the bid that's going to enter into the auction for that good is going to be the pacing multiplier times the value that the bidder has for that good. So that's why the bids that enter the auction are half of what they were. Now, the little bit of leeway that I was talking about in terms of the allocation, that is needed in order to come up with well, I guess I'll get to this in 30 seconds anyway, but, oh.
Pacing does not have anything with the budget. Because generally pacing means pacing the budget. But here is currently at least not connected.
So we're focusing on the static problem here. So I'm not making kind of any differentiation as to what happens when in time. But obviously in a real system, it would be that you look at the budget, your spend, and you have the pacing parameter based on that. But here, because we're in the static setting, there's just a single number.
But it is about budget. Right?
It is about, yeah.
About cases where if you were to bid naturally, you would end up overspending your budget. So we're going to bring down your bids according to this pacing multiplier so that you don't overspend your budget.
But I mean, you don't know this. You should figure it out. What are the factors that you want to put in? And in the online, things that may decide essentially, you may decide online. But here you want to do it offline.
That's right. That's right.
Is this multiplier limited to 1 or it can be greater than 1?
It is limited to 1. Yeah, that's right. That's right. So what properties do first price pacing equilibria have? So the first thing that we show in the paper is that there exists a Pareto dominant budget feasible set of pacing multipliers. Pareto dominant in the pacing multipliers. So there is a budget feasible set of pacing multipliers where each of the alphas is higher than any of the other for any other BFMP PM. Moreover, this BFPM does not have any unnecessarily paced bidders, and therefore it satisfies the last condition as well of a first price pacing equilibrium. So because the set of BFPMs is non-empty, I just gave you one, the 0 pacing one, that must necessarily mean that first price pacing equilibria exist. Moreover, any BFPM that is dominated by some other one must have an unnecessarily paced bidder. So that means that these are essentially, the first price pacing equilibria are essentially unique. Essentially has an asterisk because they're unique in the pacing multipliers, but due to ties, the allocation may be different. This does not impact revenue, social welfare, or utilities of the buyer, so in that sense, it doesn't matter that much. Finally, if one BFPM dominates another one, its revenue must be higher. And since a first price pacing equilibria dominates all of them, that means that amongst the set of BFPM, the first price pacing equilibrium is revenue maximum. I'm going to go through this rather quickly just to make sure I end up on time. But what are some of the other concepts that first price pacing equilibria are related to? Well, there's the concept of an equal rates competitive equilibrium, which is a competitive equilibrium where bidders have constant bang per buck, and there's an equivalence between first price pacing equilibria and those competitive equilibria. Shield-proofness means that a seller cannot benefit from adding fake bids. First price pacing equilibria satisfy that. In the core, no group of bidders have a deviation with a seller that is simultaneously beneficial for all. This satisfies that as well. And then finally, there's a definition by Okke and Lee on credible mechanisms, which state that the seller cannot benefit from lying about what other bidders have done. And it turns out that this is not true for FPPE. So while there's many sort of related concepts that are closely related to FPPE, this last one is not satisfied. So all of these are about, given an input, what are the properties of this solution concept that we have. But what about if the input changes slightly? So if the input, for example, if we add a bidder or a good, then ideally we want revenue to, say, only go up if we get another bidder. What we show is that revenue indeed for bidders, additional goods, and for increased budgets, revenue can only go up, though it is not true that if valuations go up, that revenue necessarily increases. Things don't look quite as good for social welfare. Adding a good still increases social welfare, but in the other cases, social welfare can go either up or down. But the elephant in the room, and the thing that I haven't addressed so far, is what about incentive compatibility? Like, do bidders actually give their budgets and their valuations truthfully? So what I'm going to show you here, so we have some simulations based on realistic data, though the bids here are drawn uniformly 0-1. We compute first price spacing equilibria using the Eisenberg-Gale convex program. In the paper, we show that you can do that in that way. And the graph that I want to share with you here, it takes a little bit of time to interpret. But on the bottom axis, we have the pacing multiplier. Pacing multiplier of 1 means that there's no budget that is binding. On the left, there's sort of a strong, the budget is strongly binding. And on the y-axis, what we see is the regret that you have for bidding or for truthfully reporting your budget and valuation compared to the best thing that you can do. Now, what you can see is that for pacing multipliers under 1/2, there's hardly any benefit whatsoever to misreporting your values. So if you're in an ecosystem where lots of buyers are budget constrained, then first price individual auctions aren't such a bad thing to do. Bidders can't really get any deviation that improves their outcomes. Yes?
How do you, I think that was the Vincent said, how do you generate bids in that data? Is that like some kind of simulation, right?
Yeah, so the bids here are just drawn uniform 0-1. We do have results where the bids are taken from realistic data, and these are from a Facebook data set. But unfortunately, I don't have that data here to share with people today. So my time is up here. Let me just close by saying that we started this investigation to see if it makes any sense to have individual first price auctions. We've seen that there's many good properties that first price spacing equilibria have. And if bidders are severely budget constrained, there's very little that we can expect in terms of strategic behavior. Thank you.